In this video, we're going to look at the idea of formulas. So suppose a 14-inch candle is lit and steadily burns until it is burned out. We will let the variable b represent the burned length of the candle in inches, and we'll let r represent the remaining length of the candle in inches. So as the candle burns, b and r both vary. And if we imagine pausing the situation, kind of like what I have in this diagram, then the remaining length of the candle is really the difference of the original length of the candle in inches, 14, and b. And so 14 minus b is a variable expression in terms of b that represents the remaining length of the candle in inches. But notice that this statement up here also tells us that r represents the remaining length of the candle in inches. So both r and 14 minus b both represent the value of the same quantity measured in the same unit. And therefore, these two things will always be equal. They will always have the same value. And therefore, r will be equal to 14 minus b. And therefore, we can say r equals 14 minus b. We call this equality a formula that expresses r in terms of b, because this is an expression in terms of b, and we're expressing the value of r. So that formula expresses r in terms of b. Now, formulas are quite useful because they explicitly relate the values of two quantities within a situation. And if we know a value of b, we can use the formula to determine the value of r, and vice versa. So let's look at an example of this. Suppose 3.3 inches have burned from the candle. This would entail that b, the variable b, has a value of 3.3. Now we also know that r is equal to 14 minus b, so when b is equal to 3.3, then 14 minus b will be equal to 14 minus 3.3. We're just inputting that value of b in there, and 14 minus 3.3 is equal to 10.7. And therefore, when b equals 3.3, we have r equal to 10.7, which tells us when 3.3 inches have burned from the candle, the remaining length of the candle is 10.7 inches. Now, we call this process evaluating because we determined a value of the isolated variable using a value of the not isolated variable. So whenever we know a value of the variable that we're expressing the other one in terms of, and we determine the value of the isolated variable, we call that evaluating the formula. Now, let's flip this around a little bit. Let's suppose the remaining length of the candle is 1.7 inches. This would mean that the variable r has a value of 1.7. Now we know that r is equal to 14 minus b based on our formula, and if we plug in this value for r into this equation here, we have 1.7 being equal to 14 minus b. If we do a little algebra here, maybe we'll add b to both sides. We end up with b plus 1.7 is equal to 14, which tells us b should be 1.7 less than 14, or 14 minus 1.7, and therefore b is equal to 12.3. This tells us that when the remaining length of the candle is 1.7 inches, the burned length of the candle is 12.3 inches. We refer to this process as solving an equation. So in general, if we know a value of the isolated variable, which is in this case is r, and we determine the value or values of the other variable, we have to set up an equation and then solve the equation for the other variable. And so we call that solving the equation.